Hello, and welcome to Minitab Statistics for Second Language Research. This is Lesson 3, and we will be talking about correlation, and we will learn about some basic Minitab operations. This lesson is based on Chapter 6 from our textbook, A Guide to Doing Statistics in Second Language Research using SPSS and R by Jennifer Larson Hall, although we are translating everything into Minitab. So let's get started. This lecture is going to be divided into two parts. Part 1, we're going to learn about correlation. We're going to learn how to check for normality. We're going to review, because we learned this last time. We're going to be making and understanding scatter plots. We're going to talk a little bit about the correlation coefficient. We will learn how to calculate the correlation coefficient. Then we will add a regression line to the scatter plot, and we will use the assistant to calculate the effect size. So we're ready to start. First, we're going to talk about the Pearson's correlation coefficient. This is a value that we're going to calculate, and the result is going to be between -1 and +1. The closer we are to 1, the more perfect correlation we have. And the plus and the minus here indicate whether we have a positive or a negative correlation. Let me give you an example. Here you have 3 results. The first diagram shows a positive correlation. So this means, and this is a correlation of 0.4. This means that we can trace a straight line, and this line is going to be ascending, and this is a positive correlation. The last diagram on the right is a negative correlation, also of -0.4. Now, as you can see, in this case, the line goes down. And when there is no correlation, then in that case, we will just get a straight line, and in that case, we will say that R, this is Pearson's correlation coefficient, is equal to 0. You may be wondering, what does a correlation coefficient 1 look like? So here, let me give you an example of a +1. So this is going to be a set of points in the data that are going to be in a perfect straight line, and notice it's an ascending line, while a Pearson correlation coefficient of -1 is going to be a series of points. It's exactly on a line that is going to be going down. We're never going to be getting data like this in the real world, so it will always be approximate. So the closer we are to 1 or -1, the better, or the more, that our variables are going to be related. So we're not going to go into the math for Pearson's correlation coefficient, but notice that this is the formula. It looks very intricate, and let's understand what it says. So R, this is the symbol that we use for Pearson's correlation coefficient. And how do we calculate it? Well, we take n. Remember, n stands for the number of samples that we have. We add all the values for x and all the values for y, and we multiply them, and we subtract the sum of all the values for x multiplied by the sum of all the values for y. Now, this is a very complicated calculation, but again, the computer is going to do this for you, so you don't have to worry. And that's the numerator. The denominator is going to be the square root of n multiplied by the sum of all the x values squared minus the sum of all the values for x squared, and that multiplied by n plus the sum of all the y values squared minus the sum of all the y values squared. Okay, so this is a very complicated formula, but again, the program is going to calculate it for you, so you don't need to worry. You just need to understand what the formula is asking for. So this is going to be an R value. And remember, the closer the value we get to 1, the more the two variables are going to be correlated. Together with this R value, we're going to be also reporting, and we're going to be getting what we call a confidence interval. What is a confidence interval? Well, you have the definition there. Is going to be the range of values around the statistic, in this case R, that defines the range where the true population value of the statistic will be found on repeated testing with 95% confidence. In other words, it's going to give us a value, and it's going to give us a range where these values can be found if we repeated the experiment, or we tried this experiment with the whole population. Now, of course, we're never going to be doing the whole population, but this means that if we want to repeat the experiment, our value for R should be within those values. So this is Pearson's correlation coefficient. Now, with this, in addition to Pearson's correlation coefficient, we're going to calculate what we call an effect size for the correlation. And we start with Pearson's correlation coefficient, and what we do is we square that R. Okay, so once we square that, so we also need to square the second part, we're going to get what we call the effect size for the correlation, or R square. So what is R square? R square is going to be the measure of how much the variance in one variable is accounted for by the other variable. Okay, so this is going to tell us what percentage, if you want, of the variation that we have in the variance is going to be accounted by the other variable. Now, normally this is reported two ways. It's reported in decimal terms, for example 0.654. Sometimes is also reported in percentage. So in this case, that would be 65.4. So if you have a decimal and you want to know the percentage, just multiply that by 100. If we have a 0.035, this is going to give us a 3.5%. And if we have a 0.005, this means a 0.5%. Now, of course, ideally, we want to get an R square as high as possible, so we can see that one variable is really influencing the other variable. Now, how do we report a correlation? So here's the report that Larson Hall, in her article in 2008, reported. So she says, a Pearson correlation R between reported hours of study of English and scores on the grammaticality judgment test found the effect size of the correlation was small, and the CI is the confidence interval, fairly wide, 95% confidence interval between 0.05 and 0.32, with an R value, remember R is the Pearson correlation, 0.18, n equal to 200, and R square equal to 0.3, meaning the correlation coefficient is not highly reliable. And I will leave the second part for you to actually do as part of the project for next week. Now, what is she reporting here? Well, notice she's comparing to see, well, she's trying to see if there is a correlation between the hours of study of English and the scores that the students get on the grammaticality judgment test. Okay, so she's trying to see whether there's a correlation between those two variables. What is she reporting? Well, she's reporting a Pearson correlation, the value for R, and we have it there, R 0.18. She's also reporting the effect size of the correlation. Notice that that would be the R square that we have there. And she's also reporting the confidence interval for the correlation. In this case, 95% correlation between the value of 0.05 and 0.32. Which means then that if we run the experiment again and her data, let's say we will get the same results as her data, we should be getting a value between an effect size of the correlation between 0.05 and 0.32. Notice that she also includes kind of a little explanation as to what the data shows. And in this case, it's showing that says meaning of the correlation coefficient is not highly reliable. In this case, notice that she got an R of 0.18, which is very small. Remember, the closer that we are to number 1, a value of 1, the more the two variables are correlated. So in this case, notice she only got a 0.18. So that means that this correlation is indeed very weak. Now, when we do this on Minitab, I will show you how to get this report. This report is going to include everything that she is discussing in that case. Here, notice that on the right, we get a little graph, okay? So this is what we call a scatter plot. So a scatter plot is basically going to be a graph where we're going to be plotting all the points. In this case, it's hours of study versus the grammaticality judgment test score. And on top of that, you will see a straight line. Okay, so this is the line that we call the regression line. We will talk a little bit more about regression in our next lesson. And this is showing that there is, in fact, a linear relation. Now, here at the bottom on the left-hand side, it's showing that we really have a very small correlation. Actually, it falls under what we call a no correlation. It says the positive correlation is a positive correlation. If we look at the slope of the line, we see that it's going up. So the positive correlation, R equals 0.18, indicates that when hours of study increases, JT score also tends to increase. But notice that the relation is not very strong, as she concluded in her study. Then notice that here it's also giving us a percentage of variation explained by the model. This is the value for R squared. And in this case, it's 3.4%. Notice the little explanation that you have there. It says 3.4% of the variation in the GJT score can be explained by the regression model. Okay, so only 3.4%. Again, this is going to be very, very low, so almost insignificant. But there is a little correlation there. And at the top, and this is also the result of the regression, is telling us whether there is a correlation, there's a relationship between the two, and it says the relationship between the GJT score and hours of study is statistically significant. So in this case, there is a correlation, there is a relationship between the two, and however, notice that this is very low. And there's a p-value that we will be discussing a little bit more when we start talking about regressions. Okay, so this is what the program is going to summarize for us, and we're going to learn how to do this, and now you know how to read it. So, now then, we're ready to go to Minitab. Let's go to Minitab. Okay, so here we are now in Minitab, and we have opened the file Larson Hall 2008. Notice that we have three columns. The first column is we have the results for the grammaticality judgment test scores. Second column we have the aptitude score, and the third column there we have the hours of study. Now in this lesson we are going to see whether there is a correlation between the score, the JT score, and the hours of study. So we're going to see if there's a correlation between those two variables, and then for the project for next week, I'm going to ask you to see whether there's a correlation between the score and the aptitude score. So the grammaticality judgment test score and the aptitude score. So now we will do grammaticality judgment test scores and hours of study. So how do we do a correlation? Now before we do any parametric test, we need to check whether the data that we have are normally distributed. Remember, this is going to be crucial for any parametric test. Now we learned how to do how to check for normality. So what we do is we go to stat, basic statistics, so stat, basic statistics, and then we go down all the way to normality test. And then we want to check whether our grammaticality judgment score is going to be normally distributed. Now, to do that, in language acquisition, we typically apply the Shapiro-Wilk test, which here is called the Ryan-Joyner. It gives us the same result. So we click here, and we got a probability plot that you already know how to read, right? So we can see here that the points pretty much stick to the straight lines that we have there in the middle. So we know that this is going to be, just by looking at the plot, that this is normally distributed. But we can confirm that looking at the p-value here on the right. And we can see that we have a p-value of 0.100, which is higher than 0.05. So if you have a p-value higher than 0.05, then we can conclude that our data are normally distributed. So in this case, yes, our data are normally distributed, and we can proceed. Okay, we can proceed. This normality test is going to be very important when we have few pieces of data. If you have a large number of data, then that's okay. But if you have few, test. But it's always good to test. All right, now, so we're ready now to do the correlation. So how do we do the correlation? It's very simple. We just go to Stat, Basic Statistics, and you can see here that if you go down, there's going to be a point here for correlation. So we go Stat, Basic Statistics, and then we go down all the way to correlation. Now, it's asking us what variables we're trying to see if there's a correlation. So we're trying to see whether the hours of study and the grammaticality judgment test scores are going to be related. So we just click on those two. Click on that, and we get this graph here. Now the graph looks pretty messy. It's just a bunch of points. However, it does give us an R value, as you can see here, and this R value is R.184. Now remember that the closer we are to 1, the higher the correlation. So in this case, this is telling us that we have a very low correlation, and that's exactly what Larson Hall concluded. There was a very low correlation. It's also giving us here the confidence interval. This is a 95% confidence interval, which varies then between 0.047 and 0.315. So if we repeated this, we would have values between these two values here regarding the R. Now, if you want to see a straight line, notice that we're predicting then that the slope is not going to be negative, it's going to be positive. Okay, so you double click anywhere on the graph, and we add, and you want to add what is called a regression fit. Okay, so I repeat, double click, right click anywhere on the graph, add, and you're going to add a regression fit. And we want to add a linear line, okay, not a quadratic or cubic. We will talk about those later. Just a linear line. Now, notice then that we do have a linear relationship here, the moment that you can trace that line, and notice that it has a very, very limited slope, 0.184. So the relation here that we have is going to be very, very, very limited. Okay, it's going to be a very low correlation. All right, so this is the way then that we would do this graph, and you know how to send this to your report. So you go here, you click on this arrow here, and then you send it to Word if you're writing the report in Word, or PowerPoint if you're preparing a PowerPoint. However, Minitab has a very powerful assistant program that we have here, and this is going to give us that big graph that we got, that I showed you at the end of the PowerPoint presentation. So what we do here is you go to regression. Next chapter we will be talking about regression, but we need to do this so we can see what the R-square value is going to be. So click on regression. All right. So that's then going to open our line here, and we're going to do a simple regression. One more chapter we will do multiple regressions. So now we're just doing simple regression, and here the y column, this is pretty much going to be what we want the result to be, what we are predicting. So we're trying to predict the grammaticality judgment test score, and the x value here is going to be then what we're using to predict. And in this case, we're trying to see whether the hours can predict the GT score. Actually, at this point, it doesn't matter. When we do regression, this will matter, but for the moment, it doesn't matter. Okay, and we do want a linear equation. Okay, we want a linear relation in this case, because this is what correlation is. Correlation is a linear correlation. All right, so we click OK, and we are going to be getting a bunch of graphs. Okay, so here's our graph. Let's make it big so we can see it. And you can see then here we have a little graph with all the points. This is what you will need to include in your report. And we also have what we call the regression line. Okay, again, don't worry too much about this. This is basically showing that there is a linear relation. Okay, now here at the bottom on the left side, you can see then correlation between y and x. Okay, correlation between y and x. Notice that is telling us that we got a value of r of 0.18. That's what we reported before. And it says the positive correlation r equals 0.18 indicates that when hours of study increases, the scores also tend to increase. Okay, that's because we have this positive line here. But notice that this r value is very low, and you can see here that it's in the domain of no correlation. Okay, very low correlation. There is a correlation, but that correlation is very low. Now, the next question then is, what percentage of the data is this variable going to explain? In other words, when we look at the hours, what percentage do the hours explain in terms of the GT score? And in this case, it's only 3.4%. It's a very low percentage. Okay, so there's a very little impact of the hours of study in relation to the score. Okay, and then finally, at the top of the screen here, it says, is there a relationship between y and x? Now, this is going to be the result of the regression analysis that we will study next time, but we can already read it. And it says, the relationship between the grammaticality judgment test score and the hours of study is statistically significant, and then there's a p-value that we will understand next session. So there is a correlation, there is a relation also, and that relation is significant. Okay, statistically significant, we say. So basically this you need to include in your report so that we can see the results here. Everything is summarized here. So everything that Larson Hall included in her little summary, the written summary, is here in this chart. So you should include that chart, and now you also know how to read that chart. Again, if you want to send this to Word or you want to send this to PowerPoint, just click on the arrow here and you will get then the form to send it. Okay, so click on the arrow here and you can send it to Word or you send it to PowerPoint. All right. Okay, now we are ready then for part 2. In this part, we're going to learn about some useful Minitab functions that we will need for our future programs. We're going to learn about recoding. We're going to learn about unstacking, and then we're going to review how we check for normality and correlation. The data that we're going to use is data that we had used before. This is from the Kaiser 2000, the robustness of critical period effects in second language acquisition. Here he had 57 Hungarian immigrants, and he gave them a 200-point grammaticality judgment test. And he's going to correlate the grammaticality judgment test scores with the age of arrival, see if there's a connection. And then from the graphs, as we will see, there will be two very clear groups. So there will be a group 1 that is going to be the people under 15, and there's going to be a group 2, which is the group over 15. And when you worked on these data before, I had already separated the files for you. So now we're going to learn how to separate the files so we can use this function in the future. So let's look at the original files so we can learn about recoding and unstacking. Okay, so now we're ready. Let's go to Minitab. Okay, so here we are in the original De Keyser file. We see that he has 3 columns: age, grammaticality judgment test score, and status. Let's do a graph first. We're going to do a scatter plot, and we're going to do a simple scatter plot. Now in the y variable we're going to put the score, the grammaticality judgment test score. The y is always going to be whatever we are making the prediction for. So in this case we're trying to predict the score, and in the y variable we're going to put age in the x variable. The x variable is going to be what I'm using to predict. In this case I want age to predict the score. So I put age in the x variable and I put the grammaticality judgment test in the y variable. Okay, and I click OK. So here we have the graph. Now the graph, as we saw before, is just going to be a bunch of dots. However, if you look at this graph carefully, you can see that there are basically 2 groups, and the division is right here. So the division is at about age 15. At age 15, notice the people have very high scores under age 15, and then after age 15 the scores go down. Okay, so this is why, so let me close this. This is why here under status, notice that De Keyser has 2 groups. Okay, so he divided this into 2 groups. Group 1 and lower here, see, he has a group 2. So here, for example, in data number 20, age 30, that belongs to group 2. So you belong to group 1 if you're under 15, and you belong to group 2 if you're over 15. So that was the cutting point, as we saw in the graph. Okay. Now, when we do the basic statistics, let's do the basic statistics so you can see what we're trying to do here. So we're going to do, in this case, the grammaticality judgment test score is going to be my variable, and I'm going to have that divided by another variable, which is going to be then the status. Okay, so the real variable is going to be the grammaticality judgment test, but notice that I am dividing this, if you want, by the status. Okay, so I click OK, and I'm going to get then my basic descriptive statistics. So I have the mean, the standard deviation, the variance, the median, and the IQR. Notice that under status it says 1 and 2. So this is not very informative, and especially if I want to include this in my report, it might be more elegant to say that instead of number 1 I had under 15, and then for 2 I had it over 15. So how do I do that? We're going to recode. So we go to data, and then under data you're going to go here to recode all the way down. So data, recode, and we're going to recode to text. We're going to put under and over 15. And we are recoding the status in this case. So we double click on the status, and the method then, we are going to recode individual values, because that's what we had originally. We had individual values. So we had a value of 1 and we had a value of 2. Now 1, we said that was under 15, so I'm going to put here under 15, and then 2 is going to be over 15, over 15. Okay, so I am recoding. I am taking this value 1 and I am making it under 15, and I'm taking this value 2, converting it into over 15. Click OK. And notice that now everywhere where I had a 1, now it says under 15, and where there was a 2, like here, it says over 15. So basically I changed those numbers into a text. Now why is this nicer? Well, if I do my statistics again, notice I'm going to do basic statistics, display descriptive statistics, and I'm going to get the same. Now instead of the status, I am going now to put the recoded status that we got, and I'm going to click OK. Notice that now I am going to get a chart, and the chart is going to say under 15 and over 15. So this is much more legible. This is much more elegant than having group 1, group 2. It will save you a few words. Okay, so this is what we call recoding. So what we did here, we recoded. So we recoded number 1 into a text under 15, and number 2 in the original one to over 15. So this is what we call recoding. Now we want to see whether there is a correlation between the age and the score, the grammaticality judgment score. So how do we do that? We go to Stat, Basic Statistics, and then we go all the way down to Correlation. And here I am going to enter then the age and the grammaticality judgment test score. So that's the correlation that I am trying to determine. Notice that I got my graph again, and I got here a value of 0.619 negative. Okay, so this means that there's a negative correlation. We can prove that if we impose on this the regression line. So for that, double click, right click, add, and then we're going to add the regression fit. Click OK, and you can see that we have a descending line. So this is why we have a negative value. Notice that I got a value of minus 0.619. If we get anything higher than 0.5, positive or negative, that's a pretty good correlation. So in this case, we have a strong correlation between age and results on the score. So notice that we can do that. Now, so we have proved that there is a correlation between age and score. Now, we saw that there were two groups. So the question we want to tackle now is whether we are going to have a correlation within the group. So the first group, is there a correlation, and is there a correlation with the second group? So how do we do that? So notice that to do that, we would need to separate what we have here to see whether we actually have a correlation. Because you see, when you do the correlation function, let's go back to the correlation function, Stat, Basic Statistics, and Correlation, it only asks for the original variables. It doesn't let you see or enter any of the recoded variables. So notice that in this case we cannot separate them by age, for example, or by status. So what we do in this case, let's just leave it there, we need to unstack. Okay, we're going to unstack the scores that we have here. So how do we unstack? We go to Data, and we're going to unstack. Okay, so we have here unstack columns. That's what we're going to do. And what are we going to unstack? Well, we're going to unstack the grammaticality judgment scores using the subscripts of the recoded status. Okay, we recoded that under 15 over 15. So what are we doing? We are separating now the scores according to the recoded status. In other words, over 15 or under 15. And here we want them after the last column. It's always better to have everything in the same worksheet. Okay, So we click OK, and notice then here we have then all the scores for the group under 15, and we have all the scores for the group over 15. So what we have done is we have taken all these scores and we have separated them according to the data that we have in C4. Okay, this is what we call unstacking. Okay, so we have unstuck the scores according to the recorded status. Now we also want to unstuck the age, so we can actually do the correlation between the age for each group. So how do we unstuck the age? So again, we're going to go to data, and we're going to go to unstack columns here, click, and what are we unstacking now? We are going to be unstacking the age, and we're going to be unstacking the age according to the status and the recoded status. Okay, so what we want is the age separated depending on whether we have the first group or the second group. And again, this is going to appear after the last column, so we go here and we got that there. Okay, so what have we done here? Basically what we have done is we have said, okay, for example here we have age 8 score 170, age 11 score 181. We separate that, so here we have 170 score 170, age 8. That's what we had in C1 and C2. See, score 181, age 11. Okay, so we have separated the age. So now we can actually run a correlation between the age of the first group and the score of the first group, and the age of the second group and the score of the second group. Okay, so let's run the correlation for the first group. Is there a correlation for the first group? So we go basic statistics, and again we're going to go to correlation. Now here then we have to be careful with what we enter. So we're going to take the score for the group under 15 with the ages for the group under 15 and try to see if there is a correlation. Now we got the graph. Now this graph is what we had before, very small. Now it has been blown up. Notice that we got minus 0.257. So there's a very small negative correlation. Let's check and see if we actually get a descending curve. Descending line. So we go add, and then we're going to add regression fit. Okay, click OK, and we get the line here, and as we can see, the line is descending. So this is why we get a minus. Now the R score in this case is minus 0.257. So this is a very low correlation. Okay, so for the first group we got a very low correlation. Let's see if we can get a correlation for the second group. So again, we go to stat, basic stat, and we're going to go all the way down to correlation. Okay, now in this case we're going to correlate the age over 15 with the score under 15. Okay, so make sure we got over in both cases. So we click OK, and we're going to get the graph again. Here's the graph. Now we got an R of negative minus 0.028. Notice this is a very low correlation, and it's negative. So there's still a correlation, but it's very low. And in this case, notice that we go to regression fit, and as we can see, this line is almost going to be flat, and this is because it's very close to 0. Remember, 1 means strong correlation. Whether you have a positive 1 or a negative 1, that's a strong correlation. If you get 0, that means no correlation. Here there's almost no correlation between that. So what's interesting then about these data is that there is a correlation when we look at the general age. As we can see here, there is a correlation when we look at overall all the data. And in fact, if we have these two groups, okay, so there's going to be one group here that performs very well, and there's another group that is going to be performing less well. And there's a strong correlation when we look at age and let's say performance on the score. However, when we look at just this group here, there is a very small correlation, and then when we look at this group here, there's even smaller correlation between age. Okay, so the big group, yes, there is going to be a correlation, but when we take the particular groups, there is no correlation. We can reconfirm our results if we go to the assistant. So let's go assistant, regression, and let's do simple regression. We're going to do the big group first. So in this case, we had the scores. Remember, the Y column is always the prediction. Okay, so the prediction, we're trying to predict the score. And what are we using to predict the score? We're using the age. So we're doing the big group now, and we want a linear relationship, a linear correlation. So here we have it. We got the chart, and we know how to read the chart. So we saw here that there is a negative correlation. Okay, the regression line is descending. We can see here that we are already in the green area, so that means it's a medium correlation. So the negative correlation R equal minus 0.62. Okay, so we're minus 0.62, then indicates that when the age increases, the score tends to decrease. This is why we have a negative correlation. Notice that if we calculate from this R value, we calculate R square, this is going to be what percentage of the variation is explained by the model. We see that there's a 38% explained by the model. This is pretty low. Although there is a big correlation, we do not explain. This cannot be the main factor to explain the grammaticality scores that we have. And then finally, is there a relationship between Y and X? Then here it says the relationship between the grammaticality judgment test score and the age is statistically significant. Okay, so there is a correlation, there is a relationship between X and Y. And again, it doesn't say, here we can see that it's only 38% that accounts for that. Okay, now let's try to see whether the particular groups do that. So we can also do that with the assistant. So let's go to the regression again, but now we're going to do the individual groups. We have to do one at a time. So what we do here is we are trying to predict the score for the group under 15. We need to put that, remember, we put the prediction under Y. So the Y is always the prediction. So we put under 15 there, the score under 15 in the Y column, and then in the X column we're going to put the age under 15, linear relation, and there we go. So now we get our values here. We see that there's still a negative correlation between the two. In this case, we got minus 2.6, and this is in the no correlation area, or very low correlation. So notice that it says here the correlation between the grammaticality judgment score under 15 and the age under 15 is not statistically significant. So the correlation is not significant, okay, because it's very low. So it's in the no correlation. How much does it predict? Well, it predicts only a 6%, so very, very low prediction. And here it says that it's not, the relation is not statistically significant. Okay, so here we saw that there is no correlation and there is no relation between the age and the grammaticality judgment score for those under 15. Okay, now let's see what happens then when we have for the group over 15. So again, we're going to go to the assistant and we're going to go to regression again. And we're going to do a simple regression. And in this case, we want the score for over 15 with the age over 15, and we still want a linear equation, a linear relation. So let's click OK. And we're going to get our charts here. Notice again, this is where we got the almost flat line there, showing that there's very, very little correlation between the two variables. Okay, so we got here the value. Here we got minus 0.03. Okay, so in this case, the correlation between the grammaticality judgment test score over 15 and the age over 15 is not statistically significant. Okay, so notice it's almost no correlation. It's very close to zero. How much can we predict with this? Well, notice that we predict 0.08%. That's practically nothing. Okay, so this when we take the age over 15 and the regression, there is no relation there. And then, is there a relationship? Well, in this case, it says that it's not statistically significant. So the relationship between age over 15 and regression and score over 15 is not significant, is not statistically significant. Okay, so with the assistant then we can prove, or we can check ourselves and see whether we got good results when we were doing the individual tests. So the grand conclusion here then is that yes, when we take the group, the big group under 15 and over 15 together, there is a statistically significant difference, and there's this a correlation, because we're really still studying correlation. But when we took the groups individually, trying to see if there's a correlation between the age and the score that they get in the particular groups, there is no correlation. It's not significant. So what have we learned in the second part? Well, basically we learned two techniques. We learned first the technique of recoding. So recoding is whenever we want to change the name of a value so we can make it more legible, then we use recoding, and this is all under data. So if we click data, we see that here we have at the bottom almost the function for recode. And then we also use the function of unstacking. Sometimes we're going to just get two columns when we should have, like in this case, we had 4 columns, the information for 4 columns under 2 columns, so we can unstack those columns. And also for that we go data, and then we have here the function unstack. Okay, now what we need to remember about this, however, is that when we unstack, we need to unstack a particular set of data, but we're going to be using the subscripts in another data. Okay, in another set of data, in another column. Okay, so we have to be careful with what we enter where if we want to do this right. And always we can always double check what we have done when we use the assistant. Okay, time has come then to summarize what we learned today. First, we talked about Pearson's correlation coefficient, and we said that this could vary between -1 and +1. The closer we have the values to 1, the more, let's say, the better the correlation. And the closer the number is to 0, that means no correlation. Correlation can be positive, as the diagram on the left, or it can be negative, as the diagram on the right. When there is no correlation, we get a flat line, and that's when R equals 0. The formula to calculate R is what you have here. We don't need to worry too much about the math, because the computer, the program, will calculate this automatically for us. And together with R, we're also going to find a confidence interval. So this is where the values of R can vary when we move to another sample or we move to the population. when we plot this in Minitab, we will get a graph like this. We can add what we call a regression line, and we will be talking about regression in the next lesson. And as you can see here in this diagram, we get a value for R. So this is Pearson's correlation coefficient number. And we also get a confidence interval. Okay, so this is where the values can be found. When we use the assistant, we get this big page here with all the information summarized here. On the right, we get the graph that we saw before with the regression line. At the bottom here, we get the results of the correlation. So in this case, it was a correlation of minus 0.62. Notice that that correlation is negative, and we see that it is in the middle range. So that means it's negative. Notice we get the evaluation there. It says the negative correlation indicates that when age increases, the grammaticality judgment test scores also tend to increase. So notice that we do get here a good correlation. Any value that is higher than 0.5, positive or negative, is going to be considered a good result. Here we also get the value for R square. And this is R square, remember, is the percentage of variation that can be explained by the model. This is a result of the regression that we calculated here. Now in this case, the R square value is 38.33%. What this means then is that 38.33% of the variation in the grammaticality judgment test scores can be explained by the regression model. In other words, age as a factor can account for 38.33% of the variation that we find in the scores. There's a further graph on top, but we don't need to worry about that until the next lesson. Okay, time has come for us to discuss our projects for next week. The first project is by Larson Hall, as we discussed before. This is from her article, Weighing the Benefits of Studying a Foreign Language at a Younger Starting Age in a Minimal Input Situation. This is a study that appeared in Second Language Research number 20. I will not discuss the details since we did that in the main lesson. So your tasks for this set of data: 1, you will see if there is a correlation between aptitude score and the grammaticality judgment test score. You will draw a scatter plot with a regression line, and you will show the results of the regression produced with Minitab's assistant. And finally, you will discuss the values for R and R square. That's project 3A. Then project 3B, this is with a new set of data. This is from Flege and many other researchers, and the article is called Age Constraint on Second Language Acquisition. This appeared in Journal of Memory and Language number 41. In this article, they had 240 Korean immigrants, and they were trying to see if there was a correlation between English pronunciation and the age of arrival. The English pronunciation was judged on a scale from 1 to 9, and the age of arrival was there. Now, the data here are divided into two groups. Group 1 is going to be the group under 20, and then group 2 is going to be the group over 20. So you're going to have to apply some of the techniques that we learned for unstacking and also for recoding. So the first point is you're going to check whether the entire group meets the normality condition. Number 2, you're going to test the entire group to see whether there is a correlation between the age of arrival and the score on the pronunciation test. You're going to discuss the values for R and R square, and you're going to adjoin the first chart produced by the Minitab assistant. Third task, you're going to test the individual groups to see whether there is a correlation between the age of arrival and the score on the pronunciation test. Then you're also going to discuss the values for R and R square for each group, and you're going to include the first chart produced by the Minitab assistant. And this brings us then to the end of lesson 3. I hope you enjoyed the lesson and you learned lots of new things. See you next week.